So this video, we're going to go through the first page of the MyMaths 3D Pythagoras. It's quite tricky, but we'll talk through it. So we're finding the length x in all of these. Give all your answers correct to one decimal place, so we'll need to do that. So for 3D Pythagoras, this is the most sort of standard question you tend to see. The MyMaths does go on to make it a little bit trickier with the rest of them. For 3D Pythagoras, you tend to have to do 2D Pythagoras 2 times, sometimes more. And you have to visualize the 3D space as well. So we are wanting to find x, which is going through this shape, but we can't find it straight away. But let's draw out what we need to. So if I draw our right angle triangle, in the right direction hopefully. There we are. So I'm going to draw out my triangle that we're looking for our x first off and see what we need. So there's my x. Now this line, highlight it in green here, this line here is going to be this line here in the shape. That's what we're visualizing. So actually we have that length already. It's 1.5 centimeters. And you've got your right angle in there. Okay, this bottom line along here is actually that line there. So that line and that line are the same, but we don't know that length yet. So this is where we have to go and do another right angle triangle separately to figure out what that line is. So if we once again draw our right angle triangle, it can be that side if we want. This triangle is like a bird's eye view of the shape. So if we're looking down in the shape, this side here is the same as this side here. So that's our 3 centimeters. And then we've got our along the way. So our along the way here to create our angle, that's our along the way there. And that's going to be 5.4 centimeters. And then our line here is the same as the red line in our left-hand triangle and in the shape. So they're all the same, that diagonal at the very bottom of the shape that we're looking for. That's what we want to find first because we've got enough information here. Let's call that y because x is the final thing we're looking for. Okay. Y, it's across your right angle, so this is our hypotenuse, it's the longest side. So we've got our C there and our A and our B. Our order doesn't matter for our A and our B are shorter sides. So C squared equals A squared plus B squared. And we slot in what we know. I'm going to give myself more room here. So in this case, y squared equals 5.4 squared plus 3 squared. So y squared equals, now you've got your calculator, 1 decimal place means we've got our calculator, so 5.4 squared, type that into your calculator, plus 3 squared equals, pressing my change button, and my calculator gives me 38.16. So that's y squared. Y is going to be your square root of that. Now, you could leave that as it is because it's exact, or you could press the square root in your calculator. But then you're going to get a long answer that you don't want to round. So it's up to you. It's up to you which one you want to do. 6.1773 ... But you'd have to keep that long in your calculator. Okay. Now, that's the length of our red line, so we can fill that in over here. So either that is the square root of 38.16 to keep that exact, or you could write your 6.1773 ... But it's nice to keep it exact. Okay, now we've got enough information to find our x finally. So C, A, B. So again, we're looking for our hypotenuse. So our C squared equals A squared plus B squared. So x squared equals 1.5 squared plus, just put that in a bracket, square root of 38.16 all squared. That square root and squared is just going to cancel each other out, but I'll still type it into my calculator so I know what I need to do. So x squared equals, and then go to my calculator, let's type it in, 1.5 squared plus, open your bracket, square root 38.16, use your arrow to go across, close your bracket, squared equals, and you're going to get 40.41. And then x equals the square root of 40.41, and that will equal your square root, and you can just press equals because I hadn't cleared my calculator, and you get 6.3568. Now, remember at the top it said 1 decimal place, so you need to make sure to write that to 1 decimal place, and you'll get 6.4 centimeters. And you're done and dusted. So be careful in your MyMaths, they generate different numbers, so your numbers are probably going to be different from mine, but just thinking about it as two Pythagoras. Once you've set it up, your Pythagoras work is fine. It's the setting up of the triangles, that's the really tricky bit of it. Okay, we're going to do our second question now, and then I'm going to leave you with that and see how you get on with the rest. So, the shape is the corner of a cube. So we've got our 3.4 centimeters, that must be the length of the sides of our cube. X is the height of the triangle ABD, so it's this diagonal height here, and we're trying to find our x centimeters. So again, let's set up our first triangle, see what we need to find. Triangle's not playing ball. Take two. There we are. Okay. So I am going straight for my right angle triangle here. Now the right angle triangle I'm drawing out is this one here. The sort of D at the top, B down here, and I'm only going halfway in. And our x is our height of that. So this is what we're wanting to try and find. Now, for this triangle here, I don't have the length of that line DB, so I'm going to have to find that. So I'm going to be able to find that. And I also don't have the length of that bottom line either, so I'm going to have to figure that out too. So one thing at a time. Let's find our DB. So I'm going to work with thinking about the sideways. So I'm thinking about that as my sideways view. That's D going down to C. There's your right angle, and then it's across to B. Okay. So that line DB, which I've already had, yeah, is the same as this line DB over here. So once I find that, I'm going to be able to fill that in. So DC was 3.4 centimeters, and BC is also 3.4 centimeters. So let's see how we go here. We're going to find our line DB. Let's just call it DB, and we know that that once again is our hypotenuse. So A and B doesn't matter. C squared equals A squared plus B squared. We can go DB squared equals 3.4 squared plus 3.4 squared. If we type that into our calculator once again, 3.4 squared plus 3.4 squared equals 23.12. And then DB is going to be the square root of that, 23.12. Now again, you could type that into your calculator, get your long answer, but it's nice to keep it nice and exact here. So we have that answer. So our DB is the square root of 23.12. Now, we still need to find the length of that bottom line before we can go for our x. So I'm going to draw another triangle here, and I'm going to draw the kind of bottom one, the base one, so the ACB. thinking about it in that way. A to C to B. Again, this is our sort of bird's eye view here. So A to C is 3.4 centimeters. C to B is also 3.4 centimeters. And we want to find the length of this line here. We actually only want half of it. We only want it from there to there. What you might notice is that you've actually already done the sum for this, which is really handy. We are finding our hypotenuse once again. And our A and B are the exact same as what we've just done above. So our line A to B, this orange line, you could go through the whole thing, but you're going to do the exact same sum as above, 3.4 squared plus 3.4 squared, which is going to give you 23.12, and then you square root that. So AB is going to be the square root of 23.12. But we only want half of that. So this time, we could literally just write, let's call that wee one y. So we'll go with that little bottom one, y is going to be half the square root of 23.12. And it keeps all your numbers exact. And you can fill that in here, because there's your bottom bit. Half square root 23.12. And now you are good to go to find your x value here. Now be careful, this time our hypotenuse is over here, our x is one of our shorter sides. So shorter sides, subtract a squared equals c squared, take away b squared. So x squared equals square root of 23.12 squared minus, I'm gonna have to give myself more room. Let's move all this over. There we go. Minus your b squared, which is a half square root of 23.12 all squared. Looks very messy, but we can just type it into our calculator once again. Open your bracket, square root of 23.12, close your bracket. Oh, no, go back and delete. I didn't use my arrow. So open your bracket, square root 23.12, use your arrow, close your bracket, squared. Take away, open your bracket, a half or 0.5 times by your square root of 23.12, use your arrow, close your bracket, all squared, equals, and you should get 17.34, and then x will be the square root of 17.34, which will give you square root equals 4.1641 and again to one decimal place 4.2 centimeters. And that is you done. The setup is very complicated, but once you've got it set up, you can get lots of marks for doing lots of Pythagoras work. So making sure that you draw lots of sketches of 2D right angle triangles will make life much easier for you. So try that out. Good luck with them. Let me know if you need any more help.